Good evening, Titans. This is Mr. Simpson again, and going to be looking at lesson 2.1. And so this first unit that we do encompasses some of chapter 1 and some of chapter 2. So today we're going to be looking at just sets of numbers that we deal with, and positive and negatives and absolute value and so on and so forth. So I want you to take a look at this teaser question and see if you could arrange the following numbers in order from least to greatest. So if you take a look at the number line, and if you were to place these numbers on the number line, would you be able to place them in order from least to greatest, recognizing that there's multiple negatives on some, parentheses, absolute values, and so on and so forth. So take a stab at this, and then I'll reveal the answer later in the video. First of all, our objectives, and again, you don't need to write the objectives down, but this is lesson 2.1, and so put that in the top of your notes. And we're going to be comparing real numbers, and we'll be simplifying expressions involving opposites and absolute values. So the first thing is sets of numbers that we deal with, and you've been dealing with sets of numbers all the way in elementary school, and the very first set of numbers that you dealt with were the natural numbers, or what we call the counting numbers, because if you recognize, we start counting with the number 1. So it's 1, 2, 3, 4, and so on. No fractions, no decimals, just there. Well, the next set that we added was the whole numbers. And the whole numbers are the natural numbers, or the counting numbers, but we add 0 to it. And then a set of numbers that we deal with a lot in Algebra 1 are the integers. And the integers are all the whole numbers, but then the negative counterparts to them. So those would be considered the integers. And again, these sets of numbers that are listed on this page don't include any fractions, no decimals, all right, nothing like that. All right, this next set of numbers, and this is the set of numbers that we're going to deal with a lot in first semester of Algebra 1, are called the rational numbers. And the definition of a rational number is any number that can be expressed in the form of a over b is a rational number. So more or less any number that can be written as a fraction. Now there are two types of fractions when we try to change them into a decimal. There's one that's called a terminating decimal, and that's like the fraction 1/2. Or any time that we would divide it onto our calculator and take, say, 1 divided by 2, on the calculator we get 0.5. Because the decimal ends, just like the Terminator was designed to end people's lives, well, 1 divided by 2 is 0.5. The decimal ends after the 5. Now the second type of decimal, or fraction, excuse me, is the one where it's a repeating decimal, and it looks like this bar here should be above the 3. And so if we take 1 divided by 3 on our calculator, we would get this repeating decimal. And again, remember, you can rewrite a repeating decimal as, in this case, 0.3, and since the 3 is the digit repeating, we put a line above it. And this is a repeating decimal. Well, all repeating decimals and all terminating decimals can be written as fractions. And so all these types of numbers are called rational numbers. And so when we talk about rational numbers, it includes all the numbers on the previous slide, meaning the integers, positive and negative whole numbers, but it also includes all the fractions and decimals that we would encounter, except one type of decimal. And that takes us to our last set of numbers that kind of has its own subset, and that's called the irrational numbers. And irrational numbers are numbers that cannot be written as a fraction. So some examples are the square root of 7. One of the most popular irrational numbers is the number pi. And then this one is just a decimal that definitely has a pattern, but it's not a repeating pattern. Notice how they're adding 1 0, and then 2 zeros, and then 3 zeros, and then 4 zeros. And there's no way of writing that decimal as a fraction. And when you cannot take a decimal and rewrite it as a fraction, that's called an irrational number. And these types of decimals are called never-ending, non-repeating decimals. And we'll spend a little bit more time with irrational numbers in the second semester. And then all these set of numbers that we've talked about makes up our real number set, meaning these two sets, because again, remember, this includes the integers as well, and along with the irrational numbers, make the set of real numbers. Here's a quick visual Venn diagram of this. And again, we don't have to worry about the complex numbers at this point, but notice how the real numbers encompass all of these sets of numbers. You have the irrationals, which are the ones that cannot be written as a fraction, set off by itself. And then the rationals encompass all the integers, which encompass all the wholes, which are part of the naturals as well. All right, so negative numbers are the numbers on the left of 0 on a number line, and the positive numbers are the numbers on the right on a number line. So when we're ordering numbers, we have to think about on a number line. If we have 0 here, we have 1, 2, 3. Here we have the negatives. We want to make sure that when we're ordering numbers, the numbers that are furthest to the right will be the larger numbers. So here we just use 5 is greater than a negative 7. We have 1/2 compared to 8/16. Well, remember, we could either change them both to decimals, and if we do that, we get 0.5 and 0.5. Or if we reduce the 8/16, that would also reduce to 1/2. So here we'd have an equal sign. Here they're both negative. So when they're both negative, which one of these is closest to 0? Well, the one that's closest to 0 is the negative 4.7. So negative 4.8 is less than a negative 4.7. Then 4 2/3, remember, is just a mixed number, and that would be less than the number 6. Now when we're talking about opposites, opposites are numbers that lie on the opposite side of 0 and are the same distance from 0. So for example, the number 2, its opposite, is a negative 2 because they're both 2 units away from 0 on the number line. Well, in this problem here, we're asked to simplify. What's the opposite of a negative 2/3? Well, that'd be a positive 2/3. What's the opposite of 0? Well, there is no opposite of 0. 0, the opposite of 0 is just 0. And then here, we'd want to do what's inside the parentheses first. Okay, simplify inside first. So 7.4 minus 3.2 is 4.2. And now we take the opposite of that, so that'd be a negative 4.2. So again, key skills, just comparing. 5 is greater than a negative 12, and 9 is less than 17. Pretty basic ones there. Okay, now we're going to talk about absolute value. Absolute value of a real number x is the distance from x to 0 on a number line. The symbol, the absolute value of x, okay, means the absolute value of x. So in this case, the absolute value of 7. Well, how far apart is 7 from 0 on a number line? It's 7 units. So the absolute value of 7 is 7. Now, what's the absolute value of a negative 14.2? Well, negative 14.2 is 14.2 away from 0. The absolute value of 0 is 0, because it's 0 distance away from 0. And then the letter D, we'd have to add inside first. So we have the absolute value of 13, and 13 is 13 units away from 0. So again, a couple more. To find the absolute value of a negative 11, you find the distance from a negative 11 to 0 on a number line, and that's 11. So here are just some more examples. Here we have to do what's inside the absolute values. Absolute values are kind of like grouping symbols. So that would be 24. Then the absolute value of 24 is 24, but now they have that negative outside of that, so then we end up with a final answer of a negative 24. Again, the reason it's negative here is because the negative was outside of the absolute value. Now in this case, we have the absolute value of 12 is 12 minus the absolute value of a negative 12, which would also be 12, because again, 12 and negative 12 are both 12 spaces away from 0 on the number line, and then 12 minus 12 is 0. Here we have again, inside the absolute values, the opposite of a negative 4 is 4. Then the absolute value of that is equal to 4. But then I have that negative on the outside again, so that becomes a negative. So I get the opposite of the absolute value of the opposite of a negative 4 is a negative 4. And again, here we must do what's inside. 3.5 minus 1.7 is 1.8. Notice we do that first. We don't worry about anything with the absolute value yet. Now we take the absolute value of 1.8, which is 1.8. All right, so that's really the gist of what we're going to be discussing tomorrow in class. The answer to the teaser question is right up here, so if you want to take a look at those. And then I'd just like you to try these. I mean, we've been doing these in the video, so just take an opportunity here to take a look at this. And number one, we didn't really do this, but determine if each fraction represents a terminating decimal or a repeating decimal. And if you divide this out using a calculator or whatever you need to do, you can determine if it's a terminating decimal or if it represents a repeating decimal. And then just here, insert the symbol that makes it true. Find the opposite. Again, opposite is not the same as absolute value. And here they ask you to evaluate, which more or less means you're taking the absolute value because that's what you're asked to simplify there. So again, come to class prepared, ready to discuss 2.1, and enjoy the rest of your evening, Titans.
Made with Doodlecast Pro.